Hello guys, welcome to my channel. This is Uday Pandit and you are watching MEP Technical World. In this video, we will discuss about interlocking in relay. So, how to implement interlocking circuit between two relays having common output. Okay? So, before I start the session, I would like to request you, if you are not yet subscribed my channel, please subscribe my channel and also hit the bell icon so you'll get notification regarding my upcoming videos. So let's get started. So basically what is interlocking? So interlocking is the preventive technique which implements between two or more relays, contactor and circuit breaker if they have common output, which helps to switch on the only one relay or breaker at a time. So actually this circuit prevent from the short circuit. Okay, so at a time only one breaker or relay will allow to switch on. So this circuit allow the switch on the only one relay or breaker at a time if they have a common output. So this circuit is used in star delta starter, forward and reverse starter and ATS panel, which is automatic transfer switch. In this video we are going to use this interlocking circuit between two relays. Okay, so here I have taken 11 pin relay. So this is the Omron made 11 pin relay and this is the relay base, 11 pin relay base. Actually this part is fitted on this relay base. So before I start the connection, we need to check the wiring diagram of relay. So every relay has its own circuit diagram or pin diagram on its front cover. Okay, so as you can see over here, this is the wiring diagram of this relay. So it is on front face of this relay. Okay, so before I start the connection, we have to look into this relay diagram, okay, or pin diagrams. According to this diagram we can start the connection. Okay, so if we look into this diagram, 2 and 10 are the coil supply terminal. Okay, similarly if we look into relay base, here we have a 2 and 10 are the coil supply terminal. Okay, so these two are coil supply terminal, and 1, 11 and 3, these three are common terminal of its relay. So here we have also 11, 1 and 3 terminals on the relay base, which is the common terminal of this relay. Now here we have a 4 terminal which is NO with this one common terminal, and 5 with the NC with this one common terminal. Similarly over here 5 is NC with this one common terminal and 4 is NO with this common terminal because it is normally open, and here it is NC with this 11 common terminal and 9 is NO with this common terminal. Similarly over here 8 is NC with this 11 common terminal and 9 is NO with this common terminal, and 6 is NO with this 3 common terminal and 7 is NC with this 3 common terminal. Similarly over here 7 is NC with this 3 common terminal and 6 is NO with this 3 common terminals. Now we have got the information of wiring diagram of this relay. Now let's move to the relay connection. Okay, first let's complete the connection between two relays without interlocking. So we are not going to use this interlocking circuit in this connection. So actually let's see what happen if we are not going to use this relay circuit. Okay, So here we are on relay connection. Okay, so here I have taken LED indicator lamp as an electrical load, and this indicator lamp is operated through two power supply source. One from electric board's power supply, which is city line power supply, and another one is from inverter power supply. Okay, these are single phase power supply, and actually this power is controlled through these two relays. Okay, with the help of this NO push button. Okay, and here I have taken NC push button to switch off this system. Okay, turn off this system. Now let's complete the connection. For that, here this is the phase supply. Okay, let's take red wire and connect it to the input terminal of this NC push button, and from the output terminal of this NC push button it is connected to the input terminal of this NO push button. Okay, and from the output of this NO push button it is connected to the coil supply terminal of this R1 relay. Okay, here we have connected. Now let's move to the R2 relay. So from here, from the input terminal of this NO push button, let's take a wire and connect it to the input terminal of this NO push button. Okay, now from the output terminal of this NO push button it is connected to the coil supply terminal of this R2 relay, which is number 2. So here we have connected. Now these two relays got phase supply, but it also need neutral supply at other coil terminal. So let's take black wire from here and connect it to the 10 number terminal. Similarly, from here we have tapped, okay, and connect it to the 10 number terminal. Now we have completed coil supply connection of this relay. Now let's move to the holding circuit. Okay, so I have already discussed about holding circuit in previous video, so please check out the link for that video in this description box. So for the holding circuit, let's take a wire from this input terminal of this NO push button and give it to 4 number terminal, okay, which is NO terminal with this one common terminal. And now from this one common terminal let's take a wire and connect it to the 2 number terminal. Now we have completed holding circuit for this R1 relay. Now move to R2 relay. So for holding circuit, let's take a wire from this NO push button input terminal and give it to 4 number terminal of this relay, which is NO with this one common terminal. Now from the one common terminal let's take a wire and connect it to the 2 number terminal, which is coil supply terminal. Now here we have completed holding circuit. Now let's move to the city line connection. So here I have taken a wire which is phase supply from this city line and give it to the 11 number common terminal. Okay, now from the 9 number terminal, which is NO with this 11 common terminal, it is given to over here. So this will be connected at common bus bar, we can say. Okay, now move to inverter power supply connection. So from the output of inverter power supply source, let's take phase supply from this wire. Let's give it to 11 terminal of this R2 relay, and from the 9 terminal let's take out one wire and give it to the common bus bar terminal. So here we have connected it common bus bar terminal. Okay, so these two outputs are connected at common bus bar, and now from this bus bar let's give it phase supply. So this bulb got phase supply from this bus bar. Now let's give it neutral supply from here. So here we have completed the connection. Now let's see how it works. So initially we have a city line power supply source. Okay, so we want to switch on this relay to turn on this bulb from this city line power supply source. Okay, for that let's switch on this NO push button, because we are going to operate this relay with the help of this NO push button. So let's press this NO push button. So now if we press this NO push button, actually what happened, power will flow like this, reach to coil supply terminal, hence this relay will activate and its NO contact become NC, as you can see from here. So this, what it was NO, now it become NC. So now in this way city line power will flow like this and will reach to coil supply terminal. So this is the connection. Now let's see how it works. So initially we have a city line power supply source. Okay, so we want to switch on this relay with the help of this NO push button. So let's press this NO push button. So now if we press this NO push button, actually what happened, power will flow like this, reach to coil supply terminal, hence this relay will activate and its NO contact become NC, as you can see from here. So this, what it was NO, now it become NC. So now in this way city line power will flow like this this common bus bar, and in this way this bulb got phase power supply and this bulb will get turned on. Okay, as you know that inverter have a always available power supply source. If we mistakenly or suddenly press this push button, so actually what happened? This relay coil got power supply and this relay will activated, and hence its NO contacts become NC. Hence this power inverter power supply source is flowing like this and it will reach to this common supply source. Now both power source meet at this common bus bar and become a short circuit. Due to this bulb will get damaged and this bus bar will be also burned out and whole system will be damaged. So this is the big problem at this condition. That's why we have to implement the interlocking circuit between these two relay. Okay, that's why this circuit is not recommendable. Okay, now let's implement the interlocking circuit between two relays. Okay, again here we have a LED indicator lamp which is as an electrical load and it is operated through the two power source, one from city line and one from inverter power supply source. Okay, with the help of this two relay which is controlled by this push button, NO push button separately. Okay, now let's start the connection. So this is the phase supply point. From here I have taken red wire and connected it to the input terminal of this NC push button, and from the output terminal of this NC push button it is connected to the input terminal of this NO push button. So this NO push button actually used to activate this relay 1. So this is for relay 1 and this NO push button for relay 2. Okay, so this R1 relay is actually operated through this R1 NO push button. Okay, to give the city line supply to this bulb. Okay, and this R2 relay is operated through this NO push button which is denoted by R2. So with the help of this NO push button, this indicator will get inverter power supply source through this R2 relay. Okay, so as we know that we are going to implement interlocking circuit in this connection. So from the output terminal of this R1 push button, let's take a wire, and at this time we are not going to directly connect it with this relay coil terminal. First we'll connect to NC terminal of this R2 relay. Okay, so 7 number terminal is NC contact with this 3 number common terminal. Now from the 3 number common terminal let's take out one wire and now finally give to the relay 1 coil supply terminal which is number 2. Actually we are given the phase supply at this R1 relay coil terminal through this R2 NC contact. Okay, in this way. Now for the R2 relay coil supply, let's take red wire from this NO push button input terminal and connect it to the input terminal of this NO push button. Now from the output terminal of this NO push button, it is connected to the NC contact with this R1 relay. Okay, so 7 number is NC contact with this 3 common terminal. Now from the 3 common terminal, let's take out a wire and now let's connect it to the coil supply terminal which is number 2 of this R2 relay. In this way, this relay 2 coil supply terminal got phase supply through this R1 NC contact. Okay, so this one is actually interlocking circuit. Okay, later we'll see how it works. Let's first complete the connection. Okay, now here both relay got phase supply at coil terminal 2. Now they have also other terminal which is number 10. They also need neutral supply to operate this relay. So let's give neutral supply over here. Now from this 10 number coil supply terminal, let's take another loop wire and connect it to the 10 number of this R2 relays. Now both relay coil terminal got phase supply and neutral. Now move to holding wiring or holding connection. Now first let's implement the holding circuit in relay 1. Okay, so for that let's take wire from this NO push button input terminal, and it is connected it to the 4-number terminal, which is NO contact with this one common terminal from the output terminal of this one common terminal, and it is connected to the coil supply terminal, which is number 2. Now move to relay to holding circuit. So for that, let's take a wire from this NO push button input terminal and give it to the NO terminal of this R2 relay. Okay, so this is 4-number terminal, which is NO contact with this one common terminal. Okay, now from this 1-number common terminal, let's take a wire and connect it to the 2-number terminal, which is the coil supply terminal of this relay. Now here we have completed holding connection of both relay. Now let's move to this indicator lamp connection. Now this indicator lamp will get power from this CT line source and this inverter supply source. Okay, so for that, let's first start from this CT line or electricity board supply. From here, let's take phase supply and connect it to the 11-number terminal of this R1 relay, okay, which is common terminal. Now from this 9-number terminal, which is NO contact with this 11-number terminal, let's take out a wire and give it to the common bus bar. Here we will have a common bus bar. Now move to inverter supply. So let's take out phase supply from this inverter and give it to the 11-number common terminal of this relay. Now from the 9-number terminal, which is NO contact with this 11-number common terminal of this relay, let's take a wire and give it to the common bus bar. So this is the common bus bar. Okay, now both outputs are at common bus bar. Actually this is common bus bar. Now from the bus bar, let's take a wire and connect it to this indicator. Now this indicator got phase supply from this common bus bar, and let's give also neutral from here. So here we have completed the connection with the interlocking circuit. Now let's see how it works. Suppose our CT line is available. So we want to turn on this indicator lamp with the CT line power supply source. Okay, so for this, let's press this NO push button, okay, to activate this relay. So this indicator lamp will get CT line power source. So if we press this, actually what happened, how power will flow. So power will flow like this. As you know that this is NC push button, that's why it allows the power. Okay, and here we have pressed, that's why it also become NC, and this will allow the power, and it will go to the 7-number terminal of this R2 relay. So this is the actually NC contact with this 3-number common terminals. So as you know that this is NC terminal, that's why it allows the power to flow, and it will reach to the 3-number common terminal, and from here this power will flow like this, and finally it will reach to the 2-number terminal of this R1 relay, which is coil supply terminal. So at this condition, what happened, this coil supply terminal will get a power. Okay, hence this relay get activated, hence now its NO contact become NC, as you can see over here. Now this bulb will get power from this source, CT line source, in this way. So 9 is actually previous, it was NO, that's why it doesn't allow the power from here. Now it is NC. When this relay is activated, now this power will reach to the common bus bar terminal, hence in this way this bulb will get phase supply from this CT line source, hence this bulb will get turned on. Okay, now as you know that power is also available at inverter supply source. Okay, at this time this bulb or indicator is getting power from this CT line. Suppose we suddenly or mistakenly press this NO push button, let's see what happens. This relay will get activated or not activated. So as you know that this power is available at input terminal. Now when we press this power will flow like this and will reach to the NC contact of this R1 relay, which is number 7, which is normally closed with this with this 3-number anode terminal. However, it is activated, that's why this NC contact become anode. So this power will not get a path to reach at common terminal when this R1 relay is activated. That's why this relay 2 coil not get power supply, hence this relay will not get activated, hence it prevents from short circuit. If this is not activated, it means this inverter power supply will not reach to this common bus bar terminal, hence it will protect from short circuit. So in this way, this interlocking circuit prevent from short circuit. So here still our CT line is available, our electricity board line is available. That's why at this time, so this indicator lamp is still on with this CT line. Now suppose our CT line is absent, so we are doing here manually. Okay, so let's press this NC push button to make the CT line absent or to deactivate this R1 relay. Okay, so when we press this, means this power will break. Okay, because this NC push button become anode. This breaks the circuit, and finally relay 1 coil terminal will not get a power, hence this relay will get deactivated, hence again anode contact become NC and NC contact become anode. That's why this bulb will not get a power supply source from this EV line. Okay, hence this bulb will be off. Now at this condition, what we assume, our CT line or electricity board line is absent. Now we are going to switch on this bulb with the help of inverter supply. Okay, for that let's press this anode push button. As you know that this power is flowing like this, and this will reach to push button of input terminal. When you press this become NC, hence it allows the power, and it will reach to the NC terminal or NC contact of this R1 relay, which is 7-number terminal. So as you know that this is NC normally closed, that's why it allows the power, and it will reach to the 3-number terminal of this R1 relay, and from the output of this 3-number terminal this power will flow, and finally it will reach to the 2-number coil supply terminal of this R2 relay. Hence in this way this relay will get power and this relay will get activated, its anode contact become NC. So at this condition, this bulb will get inverter supply from this 11-number common terminal through this 9-number terminal, and it will reach to the bulb, hence it become on with the help of this inverter power supply source. Suppose now the electricity or CT line is available, okay, at this 11-number common terminal. Okay, now suppose suddenly or mistakenly we press this anode push button. Actually what happened, this power will flow like this, and it will reach to the NC terminal of this R2 relay. Previous it was NC, now it is anode when this relay is activated. That's why now at this condition this power will not get a path to reach at a 3-number common terminal, hence this relay 1 coil supply terminal will not get a power supply, hence this relay will not get activated. So that's why this CT line will not get a path, because 9-number terminal is still anode because of it is not activated. That's why this CT line will not available or will not reach it to the common bus bar terminal, hence it prevents from the short circuit. Okay, so in this way this interlocking circuit prevents from the short circuits. That's why this interlocking circuit is very important to prevent these devices from the short circuit. Okay, I recommend you, if you are going to implement such type of circuit, you must have to implement interlocking circuit. So hope you guys understand about interlocking circuit concept. So thank you for watching this video. Please like, share, comments and subscribe, and also hit the bell icon so you'll get notification regarding my upcoming videos. So thank you very much. See you again in next video.